geologists for part 2 of the Quaternary. We're going to be starting with the humans and how did they get into North America and what were some of our ancient ancestors like. Literally, humans came down through the Bering Strait when sea level was at a low during the Ice Age and traveled through more than likely an ice-free corridor that separated this ice sheet from this one. See if you can name them. This one begins with the C. Cordilleran, and the big one combined is the Laurentide. So what's this one right here? Begins with a K, see if you can remember, and then what's the L one over here? You're going to need to know those for your test. Nevertheless, we know that the corridor was never blocked by extensive ice because we can actually go look at the rock and bedrock for striations and so forth. So we know humans and animals could migrate, but the question would be, that'd been pretty rough. How did they do it? Because this was some seriously difficult times for food resources and for shelter. So we know about 25,000 years ago that there's just no evidence in the rock record, even in archaeology, that humans got to the Americas before 25,000 years ago. But starting around 20,000 to 18,000 years ago, we know for sure that humans were here. We find their artifacts that date back that far. So that puts us right smack dab during the Pleistocene. So we're going to learn about various humans today. We already learned about the Australopithecus back in Tertiary. So those species were our ancestors from way back when. And then there's a lineage break off at some point, and that started the development of the Homo species. Well, there's a variety of different Homo species, and we're not going to cover all of them today, but we're going to cover some of the important ones. So what do you need to know about the Homo species? First of all, what does their name mean? When did they live? What was a trait about them that was unique? I mean, and you'll figure that out as we go through. So let's start with Homo habilis. This is called the handyman, and one of the reasons is that we find tools and artifacts with his remains, indicating that he understood and could actually use tools by that time. Now, he lived literally until about 1.8 million years ago to about 0.5 million years ago, making this a very successful species. And one of the things I want you to contemplate is that these species of humans, there were more than one that coexisted at the same time. So there is a potential for interbreeding. And that is a thought that's interesting because we need to think about the fact that these humans probably came in contact with each other. It'd be no different than different species of mammals coming together that are the similar kind, like two different cats or two different dog type species, canine species. One more thing, what was the size of their brain? Because the brain's going to show an increase over time. So the brain cranium is measured in cubic centimeters and cc's, and so that's important because the larger the cc, the cranium actually has more size to hold a bigger brain. So with that comes increased intelligence, and we see that with the abilities that these organisms had. All right, moving into, I'm having little issues here. Moving into Homo erectus. Homo erectus is the upright man, and we know for sure he was bipedal. He lived from about 1.8 million years ago to literally 300,000 years ago. I think that's important because we also had other hominids living at the same time. We know this guy developed weapons and fire. That's important because we find charcoal with their remains. So that's a very interesting deal with a little bigger brain, 750 up to 1225 cc's. This particular hominid was able to figure out how to master one of the elements and create warmth. That's going to lead to a very interesting condition there because they're going to be able to survive in these harsh winter conditions that occur. Actually, Homo erectus is not that different from us except in their facial features. Some of their hands and their arms are a bit different. You have a a lab that you're going to be doing this week, and when we're not here on Monday, that's what your assignment is, to do the hominid lab, and that'll be due online that evening by 10 p.m. You'll just scan it in and turn it in. And it compares several humans, or at least 2 hominid species, with a chimpanzee. Now, you're very familiar with the Neanderthal man. This is Homo sapiens neanderthensis. And Neanderthal are, we know, evolved from the erectus somewhere in the late Pleistocene in Europe. Interestingly enough, we've not found Neanderthal fossils in North America, but found them all over Europe. These guys lived somewhere between 230,000 years ago to about 30,000 years ago, in which they seem to have been eliminated. Or have they, is the big question. So some of you may know Professor Brad Turner in environmental science, and Brad is very proud of his small percentage of Neanderthal heritage. He actually did some DNA testing, and he came up with, I think, 1.8 or 7%, or maybe it's 2.7% Neanderthal, but he is extremely proud of the fact that he has that, and here's why. Take a look at their brain size. Their cranium size was larger than the average hominid today, Homo sapiens sapiens. And that got up to 1450 cc's. That's pretty impressive. I'd like to have that brain power. I bet you would too. We know that this particular organism used a number of variety of tools, but the Neanderthal had a little bit of some struggles. Even though they learned how to make shelters, we know they wore clothes because we find these remains or these artifacts with their fossils. Another important thing I'd point out is they bury their dead. That's a different part of the brain, and an expanded part of the brain that actually does ceremonial and emotion-related procedures. So this is a big evolutionary development in the hominid species. However, their morphology of their bones kind of left them with a few problems. And I'll point out they're kind of bow-legged. And then you have to check out their ankles. You're going to be doing this when you do your lab. And notice there's a gap between their legs here. That would be indicated they were very strong in their calves. They have a very big chest, super long arms, kind of short and robust. What you guys call cavemen. So people make cavemen out to be stupid individuals. Probably not the case. Did they have a language? Probably not. If they had some way to communicate, we just don't have a good emphasis or record of how that occurred until we start seeing hominids drawing on cavern or caves. What we do know is that the Neanderthal was first discovered in Neander, Germany. That's where they get their name, neanderthensis. And that was back in 1856. And you can look at their face in comparison to ours. Notice that they have a real big ridge right up in here, big nasal cavity. I need you to think about why that would be. Even bigger eye sockets than us. I need you to contemplate what that could be for. So interesting, because they're completely made different in terms of some of their basic anatomy. While they have the same anatomy parts, they're different sizes, they're different shapes. What would be the reasons for that? They had prominent eyebrow ridges. So this is a comparison of Neanderthal to a Homo sapiens sapiens, which is a modern day human. They're going to have low foreheads, protruding upper jaw. What was that all about? And a strong lower jaw. Matter of fact, let's go back and look at this joint right here and show you what I'm talking about. Ours don't look that way. What would have been the spirit and intent for having that evolutionary trait? Now, this deep chest they have, there would have been a purpose for that. Can you think about why? Big eyes, big chest. Okay, they have horrible running legs except for sprinting. They would have been good sprinters. They would not have been long distance runners. So we would have, look at the builds of how we are. So we were actually built for migration, running long distance, walking long distances, and notice that our chest looks different from theirs. Theirs is broader. So that chest cavity is going to be used for sudden burst of energy, probably ambush hunting. So think about the different traits you're looking at these humans as you begin to compare them in your lab and see if you can correlate how and why they're different. We know that a number of Neanderthals have been formed or found in the Vindijai cave, and this is a very important location because this contains the Neanderthal fossils that were actually used in the DNA human genome process, where they actually did a genome scope of the entire Neanderthal gene sequence. And those fossils came from here that are about 30,000 years old. So these are the youngest hominid fossils we found of Neanderthals, and they have been and given us so much insight into this particular species of Homo sapiens. Don't forget that Neanderthals are Homo sapiens. There's really our first cousins. That brings us to Homo sapiens sapiens, which is our kind, known as modern man, and our ancient versions of us are called Cro-Magnons. These are the modern Europeans that replaced Neanderthals, or did they? The big question, did they? Because we do find traces of Neanderthal in people genetically. The first fossils date back to 195,000 years ago. So 30,000 years ago is the last Neanderthal. Then we find fossils of this guy 195,000 years ago. You can't tell me they just evolved. There was a gap. Some things we don't have the full picture, I think, is the problem, or we've just not found the older fossils of these Homo sapiens sapiens. But nevertheless, these folks were pretty well advanced, and I would have to imagine that they would have come in contact with Neanderthals, and they probably shared and traded. I don't think all of it would have been fierce fighting. What would have ended up happening as the Homo sapiens sapiens was able to migrate better with the right bones and the right skeletal makeup, they probably were able to get the better houses and travel into the neighborhoods of Neanderthals and past them. And so over time, the Neanderthals just couldn't keep up with the Homo sapiens sapiens. I could be off base there, but there is some truth to that process. In the last 10,000 years, we know that these animals have become much more sophisticated because we're a part of their kind. But even 40,000 years ago, toolkits were being made. How do we know that? We find the artifacts with the fossils. Another important thing to contemplate about this particular species of hominids is they developed culture and art. Much more advanced than prior hominids, and probably the only one closest to that would be the Neanderthal man. So this is a real development and a testimony to how quickly hominids evolved once we got the Homo species. So when you take a look at a Neanderthal skull and you look at a modern day skull, and then you look at their body plans side by side, you should see some fundamental differences. And you need to be thinking about climate. Why was the Neanderthal the shape he was, the size he was? Why are we seeing modern man in the last 40,000 years, or certainly the last 195,000 years, get longer legs, not as long arms, different chest, different jaws, different shape eyes? What's up with that? Why do these things happen? What was the evolutionary need for those traits to change? So that brings me into the Ice Age animals. For testing purposes, if their name means something, you need to know that. You need to recognize when they lived and what kind of animal they were. Are they a vertebrate index fossil for the last Ice Age? Most of them are. So the Smilodon, you probably know as the saber-toothed cat. Please don't call them saber-toothed tigers. They're not even related to tigers. One thing I'd like to point out is their jaw actually opens at about 120 degrees. And that's really important because they had to open that big in order to get those fangs into puncture their prey. So these guys would have punctured and disabled and probably dragged their prey off to die to their den. Some large cats still do that today. So this was a fierce predator getting up to about 500 pounds. But it's an interesting predator because these saber-toothed cats were built for ambush hunting, not for sprinting. So they are not like a cheetah. Now there is another cat like them that is we're fixing to learn about. We have lots of fossils of Smilodons throughout North America, and Smilodons actually would have lived even through parts of Texas, but more commonly we probably would have seen its relative that you'll meet in just a minute. We know that a number of Smilodons are found with broken teeth in the fossil record, indicating that they got a broken tooth in some kind of a prey or attack. Now, looking at a Smilodon, they had very, very short back legs and like super strong front end and a bob tail. So this is what we think they look like in comparison to the size of a modern man. If you see some of the movies like 10,000 BC, they make these animals look just incredibly huge. Not saying they weren't big, they were certainly big, but they were not as large as some of these movies make them out to be. Interesting that the Smilodon is the California state fossil because of the La Brea tar pits. The La Brea tar pits, very interesting place that you need to learn more about. Scimitar cats, love these guys. These kind of were the impressive cats of their time. One of the questions I have is why did they go extinct? Because this was an animal a little bit smaller than a saber-toothed cat, but better built. This guy was more like a cheetah. It had powerful limbs that were used for long distance running and chasing down prey. So you have to imagine that cheetahs and leopards in the wild had that ability, especially cheetahs. These guys would have been the cheetahs of their time. So their canines don't get as long, about half the size. Nevertheless, they're just super cool animals, and they definitely are found here in Texas. Stag moose. Now, I absolutely love moose, so this one's like one of my favorites. This guy was an extinct animal related to, that's a deer, that's slightly larger than a modern day moose. Well, that's just enormous. And they look like a moose in their body plan, but have horns more like an elk. Really kind of a strange animal. They were found all throughout the Midwest, so we could actually start finding fossils up near Montana, Idaho, starting looking in Kansas, Nebraska, South Dakota, and we start seeing fossils around 40,000 years ago. Then abruptly they start to go away around the time the ice melted. However, the stag moose might have even made it into about 7,000 years of time. But we just don't have enough fossils to put a strong range beyond that 11,500. This guy, super interesting guy. Megalosaurus. Actually, this is the Megaloceros. Love this guy. Talk about impressive. This is the Royal Irish elk, by the way. We didn't have them in North America, but this particular animal's name means large horns. You're like, well, duh. Look at that. What's crazy about this is that each one of the horns that you're seeing right here weighed about 100 pounds each. So this guy, take a look at his neck bones and then look at where you would have attached tendons and muscles right here. This guy had to have a neck that was some kind of strong to be able to carry that weight. And think about this. Deer lose their antlers one time a year, so this is a year's worth of growth. That's incredible. I wondered how this guy got in and out of the forest effectively with a rack that size, because you're looking at a spread of about 13 feet from antler tip to antler tip. This guy is phenomenal. So if you like big game, this is your animal right here. He is something else. All right, woolly rhinos. Woolly rhinos lived from about 20,000 to 200,000 years ago. We didn't have them in North America, but we do find them in the tundra of Europe and Asia. So you guys saw one at Life Partners, and or at least a replica, and then some bones of a woolly rhinoceros. These guys, like modern day rhinos, probably were not very good eyesighters, but had excellent other keen senses like smell and hearing. And this thing, you got to touch their horns at Life Partners, so you know what they feel like. They're made out of keratin like your fingernails are. So this animal may have survived up until about 20,000 years ago, maybe even just slightly longer. But as the ice receded and melted in the last ice age, these guys ended up going extinct. Oh, this guy is so funny. Dodosaurus. You gotta love him. This is an oversized armadillo. Almost looks like an ankylosaurus, doesn't he, from the Cretaceous. We only find this dude in South America. However, having said that, we have a relative of him that's even found fossils here in Texas. So we know that giant armadillos even were in North America, just not this particular one. They're herbivores, but they're built much like armadillos are today. These guys got up to 4,000 pounds, 2 tons. Wow, that's one large armadillo. And so these guys would have been the size of a bug Volkswagen. Just to kind of give you a laugh. That's just how funny an animal they are. Moving into a famous icon of the last ice age, which is the short-faced bear. You may not have heard as much about this as some of the other animals, but this guy lived in North America, would have lived in the mountains in areas of tundra. And this guy had long legs with a little bitty kind of squatty-bodied body. So he's kind of like, almost like a wiener dog, except he was much bigger. We find his remains all the way down into the Ozark Mountains in Arkansas. So this guy existed and had a wide range, and we think he was replaced by the brown bear, otherwise known as the grizzly. This guy is a true icon of the last ice age, the dire wolf. He is definitely a vertebrate index fossil, the largest canine that has ever lived that we found fossil record for, and lived from about 130,000 years ago to the conclusion of the last ice age. These guys, their teeth, their canines are much larger than some of our wolves today. But our wolves' body plan hasn't changed that much. They've just shrunk a little bit. So these were larger, bigger, more massive, and aggressive animals of the last ice age. So they were top predators of their time. Magatherium. This is the giant sloth. So when you think of sloths, you think of at the Waco Zoo, the animals hanging out of trees. Well, this guy would have been a tree hugger, but not in the same way that you're used to seeing. He would have been reaching for the food resources at the top of the tree. And check out this jaw right here. He needed super strong jaws to tear off the stuff that he's going to eat and actually chew it. So this guy lived from about 2 million years ago to the end of the last ice age, and this is a gigantic subfamily of giant ground sloths. They got up to the size of an elephant. These were huge. The claws on their feet kind of came up like this, so they kind of walked with their feet pointed in, and they would have been awkward walkers, but this enabled them, the morphology of their feet and their hands, in order to hold on to the tree and reach up for the branches. So this guy had to really get creative on how it works. That's why this body plan is so important. Now, it is not a predator. This is an herbivore right here. A Magatherium is a very famous herbivore from the last ice age. When you look at them, they're almost funny. Here's a Dodoceras right here, and then here's your Magatherium. Just take a look at this dude and how awkward he is. Here's the feet I was talking about, kind of walking inward right there. So imagine these guys walking around the landscape looking for food on trees, and you're just like, they're almost funny. I mean, they're just a weird animal. Not surprising they went extinct. So let's look at another famous group of animals, which I think is one of the most important group, which is the elephants. So you got to remember that mammoths and mastodons are all forms of elephants. And so we're going to look at some of the early versions of elephants, and we're going to talk about the difference between woolly and Columbian mammoths. The ancestors of mammoths entered by North America via the Bering Strait around 1.5 million years ago. We have a number of different species of mammoths that have evolved throughout North America, but the biggest and the bestest would be the Columbian mammoth. There is one known as Jefferson mammoth, then there's of course the woolly mammoth, and then the mastodon. But we know the Columbian mammoths right here in Waco because you took a field trip earlier in the semester to the Waco mammoth site. What I want you to notice in this diagram, the dots represent fossil finds of mammoths in North America. And even since this map was made, more have been found. But let's kind of put the Cordilleran ice sheet here. You put this part of the Laurentide here, the Quaternary, and then you put the Labrador right here, the other part of the Laurentide. And do you see why there's not a whole bunch of fossils of mammoths found in that area? Because that's where the ice would have been. Then look at where the dots start getting pretty dark. This is where the clusters of most of your woolly mammoths would have been. Down here is where your Columbian mammoths would have been, and over here your Jefferson mammoths would have been. So we have a very consistent look at where fossils are. Let me also point out the heaviest concentrations right in this neck of the woods. Let me explain why. Even to this day, that's supposed to be grasslands biome. We've changed the landscape in many areas by human-induced change. But even if you go to this part of the United States today, it is protected as grasslands. These guys were big giant grass eaters. And that's what they did for a living. Now, mastodons had a little bit different diet. We'll get to them in a minute. So let's start with mastodons and talk about how their teeth were and why they're different from mammoths and so forth. Mastodons are herbivores that lived all throughout the Ice Age. Matter of fact, these are probably some of the most successful elephants that ever lived because they lived starting back in the Miocene all the way into the end of the last ice age. But some of the oldest fossils of most species date back to 3.75 million years ago, actually putting them in Pliocene. But Miocene is when we get the first mastodon in the rock record. These guys don't have dense long hair. They have different tusks. They're smaller. They're kind of like the runts of the family. And their teeth are shaped different because they ate things like pine cones. That's what they did. They didn't have the same food structure or source that a mammoth did. So I think that's one of the reasons they were more successful. Nevertheless, this is a vertebrate index fossil for the last ice age because these guys made it all the way to the end. Woolly mammoths are related to mastodons. They are also herbivores, but would have focused on the savanna grasses, especially along the edges of the ice sheets of the Laurentide and Cordilleran ice packs. These guys had long, dense fur, just like you saw at Life Partners, and tiny little ears. And one of the reasons they needed little ears is the ears of elephants are used to radiate out heat. So in cold conditions, they wouldn't want that. They'd want little ears to hold in their heat. So Columbian mammoths should have bigger ears. And certainly elephants today have much larger ears because of the heat problems that they had. Woolly mammoths evolved over in Asia and Europe around 2.6 million years ago, migrated into North America, and stayed here until the end of the last ice age, where they died off around 11 to 10,000 years ago. We know there was a tiny group of pygmy mammoths that lived a little bit longer off of the island of Siberia, and those are really a cute story if you'd like to learn more about the pygmy ones. Columbian mammoths, no dense fur, distinctively much larger than the woolly mammoth. These guys lived from 100,000 years ago to the conclusion of the last ice age, so they're kind of a evolutionary benefit. They radiated off of the other elephants and found a way to get bigger and better and eating machines. If you want to control your yard, if you had lots of grass, this would be the animal to get it. So this is a classic look of a Columbian mammoth, and they are just enormous. So mammoths have long tusks, and their tusks are actually incisor teeth. They are not just a tusk like some animals have that come out for protection. They are actually teeth. And so they grow in increments. They're made out of dentin, which turns into ivory. And that dentin actually shows even seasonal, sometimes even weekly, diet changes. So if you had a really harsh eating circumstance, they'd have a small ring, like a growth ring of a tree. And if you get a wider one, that tells you that they've been had really good eating conditions. We know that they use their tusks for mating, for fighting, for protection, and even for moving stuff around so they can get to their food resources with snow. The teeth of mammoths are about the coolest thing you've ever seen. The teeth are huge. They're about the size of a shoebox at their sixth set. Now, you need to know this. There are 6 sets of teeth for mammoths. Elephants have 6 sets of teeth. Is that not crazy? And they get their teeth in a sequence of events, which we're fixing to talk about. And that'll be interesting when you look at it, because you'll be like, wow, because the first set of teeth are really tiny. Now, you have to think about a woolly mammoth eating 500 pounds up to that per day. Let's say 300 to 500 pounds of food a day. Columbian mammoths had about 500 to 700 pounds of food a day. It's astounding to me that the woolly mammoths could be sustained, as many of them as there were up north, with the conditions that they had. Not surprising that Columbian mammoths just did awesome down here, because we had tons and tons of grass for them to eat. But what happens, unlike our teeth, where we grow one up like this, it comes in a mammoth like a conveyor belt. And so it will break off these little ridges right here and peel them off into layers, so the whole tooth is coming out one piece at a time. Sometimes an entire tooth will knock out. Well, that's like a disability that can kill a mammoth. So when we find them in their jaws, oftentimes we can see a new tooth like this one developing, pushing out the old one as it comes out the mouth. So we can tell how old an animal is simply by looking at their teeth if we find them in the fossil record. So when did they get their teeth? These are great test questions. The first sets, 1 through 3, are acquired by the end of age 6, so they're your baby teeth. And then the 4th set come in around teenage years. The 5th set's supposed to last for their adulthood until they get their 6th set in midlife around their 40s. So once the 6th set's there, no more teeth. There was nobody to give dentures for mammoths, so what would happen to them? And if you're thinking, this is really sad, it is, isn't it? Because they're going to wear those teeth down, and they're going to get malnourished because they can't chew and get the nutrition they need. They will starve to death. So about as old as a mammoth can get is usually between 70 to 75 years of age. Most of them die a little bit younger than that if they're successful in living a long time, like to 60. But if you see a 75-year-old, that's like seeing over a 100-year-old human today. I mean, that's pretty remarkable that they could live that long. The tusks of mammoths are used to help us determine what their conditions were of eating and circumstances of life. We can even tell you, based on the rings that are developed, if it's a female, how many times that they were pregnant. I can't tell you how many times they had a baby, but we can tell you that they were lactating. We can tell you those kinds of things with that. So dentin grows very slowly, but within that we can see the rings of nutrition that occur from season to season, even week to week and month to month, as these things are slowly growing like your fingernails. So the annual layer of tusks provide a distinctive record of the weekly and daily eating conditions and living conditions of these animals. And the tusk growth rate would change. If you had really great eating conditions, the tusk would grow faster. So thick dentin increments of rapid growth indicate that we had great eating conditions. Everything looked great. So mammoths were matriarchal societies, where a senior elderly mammoth that was kind of the queen mammoth at the site of the herd led everybody. She had more experience. She was the grandma. And so grandmas just like to take care of everybody. And so we know that's true in mammoth mammoth herds, as well as elephant herds, are reared by a matriarchal hierarchy. So what does that mean? That means that there is an elder, like a grandma, that has been around a while, that knows the ropes, knows the migration routes, knows the risk, and she kind of runs the herd. So everybody takes care of everybody's young. And the males of the herd are usually young men, they're babies, and then by a certain age, when they get to their changes in their testosterone levels and they become a little bit more aggressive, eventually everybody runs them out of the herd. So the only times that bulls actually join the herds long for any length of time is during mating season. And if that's the case, musk, they come in when it's that period of time, they do their thing, and then they're pushed back out, because those big males could kill these babies. And so the matriarchal lineup of a elephant herd is designed that way to protect the young. So the mammoth site in Waco, you've been to it. You've seen it where it is today with an in situ shelter. So you have to imagine that this is what it looked like when they were first excavating out these fossils. We know that both males and female mammoths have tusks, and we found that certainly in the mammoth site. You saw Mammoth Q, Mammoth R, you saw some of the famous mammoths that we looked at. Mammoth W was a female, Mammoth Q was the big bull that was very unlucky with the mammoth site. And the teeth of the Columbian mammoths we have in Waco were designed for grass-eating machines. These guys were nowhere near glaciers. That's why they didn't need the thick hair and the long hair that we see like in woolly mammoths. This is what the site looked like before it became an in situ shelter. This was out where the bridge crossed over into the in situ shelter where they collected most of the mammoth animals. You can see some of the tusks there. This one actually should look familiar to you. This one's one that's actually in the building today that we saw, Mammoth Q. You start to look at this, you'll go, hey, I recognize this place. I've been there. So this would be a living fossil assemblage where we have the animals that died in place. They didn't get washed in here. And these animals represent these herds, not just once, not just twice, but 3 times, all in the wrong place over about a 20,000 year period of time. The last thing I'd like to talk about is the La Brea tar pits and then why did mammoths go extinct. The La Brea tar pits is a famous place in California, and I highly recommend going to it instead of Hollywood when you go out to Los Angeles. This area is famous because of the thousands of Ice Age animals that have been found there of all different sorts. So you're looking at mammoths, mastodons, you're looking at saber-toothed cats, scimitar cats, you're looking at just about every animal you can think of that got captured in that particular deal. This is a museum. And the tar pits, you can actually get an internship to volunteer to excavate out these during the summer months. So let's talk about the extinction event that occurred at the end of the Pleistocene epoch. Really, it's not a mass, it's more like a minor, but when you're looking in terms of this one group of animals, it was a surely mass extinction of one wide-scale group of mammals. About 11,000 to 10,000 years ago, just about every megafauna went extinct. Megafauna meaning everybody that was over 100 kilograms in size. So a 40 kilogram animal weighs 100 pounds. So an 80 kilogram would be 200. So you're looking at about 250 pounds or more went extinct at the end of the Ice Age. So everybody that was a large herbivore and subsequently the carnivores that fed on them. There's 3 major primary thoughts as to why this happened, and I'm not going to say that any one of them is completely responsible. My thoughts are the combination probably did the job. Before you laugh at the hyper disease theory, there's actually some merit to this one. So animals could have received some diseases as human populations expanded and water supplies were contaminated, they either got domesticated, a number of different thoughts could happen, or their animals came in contact, the human pets came in contact with these animals. Nevertheless, these diseases probably did impact a number of the animals, and some of them probably got diseases they couldn't fight off. There is some suggesting evidence for that. The human hunting theory is thought to be one of the major causes of the demise of these large megafauna, at least for mammoths. So about 14,000 years ago, we know that humans were definitely in North America. Definitively, we can say that because we know that we find fossils and artifacts that date back into the 20 and maybe even 25,000 marker. The Clovis people are the first known people that left really good artifacts behind. They were good hunters, and we know that they probably figured out that how to kill off mammoths, and they got better at it. And we'll look at, if you think back to Life Partners, the atlatl, that was an example of one of the tools that they learned how to make that was effective in hunting. So you put the hunting and the disease, both going to diminish populations of mammoths and other megafauna. You add the rapid climatic warming. Somewhere around 18,000 years ago, to the conclusion of the last ice age, the climates of North America rapidly warmed. And when they did, rainfall patterns shifted from being wet to more dry, glaciers melted, and you ended up with an ecosystem where the plants couldn't be sustained in the same way. Because if you think back to the tertiary, grasses are more common in cooler, drier temperatures. So we're changing our temperature range, so it's going to change what can grow there. So over time, we're going to lose the plant resource. So coupled with hunting, coupled with disease, this can end up being a real problem. So what killed these animals is not necessarily a mystery, it's just not agreed upon in the scientific community. So we know that the Waco herd of mammoths got stuck in something like a mudslide or a landslide, and this probably happened in different areas of the continent because we're finding a number of living assemblage of fossils of mammoths and mastodons, indicating that this was not the only place that this happened was in Waco. So it's the end of the semester. Yay! So you're going to need to be doing your hominid fossil lab, and that's going to be due when we come. You're going to post that online, and I'll put the information online as to when it's going to be due Monday night at 10 p.m. That gives you more than class time to work on it. So I'm assigning that in class, so you need to be using your class time even though we will not meet next week. So I hope you have a wonderful holiday, and I will see you when we get back for test number 4, the day we return back from Thanksgiving. Bye.